Hello, welcome to Mickey Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement for creating these kinds of a technical video and publishing in a public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of videos. And I would like to thank Almighty for my broad mind as well as my health. And I would like to thank my friends, followers, my dear students, and subscribers for their continuous support. Today's topic of interest is friction. Generally speaking, the friction is everywhere. For an example, if we are walking in a ground, the friction is normally in between our foot as well as the ground, then only we are in stable. You may experience the friction while a wetty surface and a dry surface, while we are walking in a wet surface or a greasy surface and a dry surface. In greasy surface, you cannot stabilize yourself. It is a bit risky, whereas in the dry surface, you can easily walk without any fear and your grip is very good. So here we are speaking the grip, which is nothing but the friction. Friction presented between the ground as well as the your foot. So this is the importance of the friction. The friction should be there. It should be there in an allowable limit. Then only it is good. If it exceeds the limit, what will happen? If the friction, force of the friction is more than the weight of a body, it cannot move. And if we want to move such a body, we require huge amount of a force in order to move that body, stabilize the body. Therefore, a friction is a very, very important concept. Either our body is in steady state or a static condition or a moving condition, the friction is applied. So, the friction is nothing but an opposite force which the body tend to move. Friction is always in the opposite direction. Say we can say a friction is a negative energy, it is always in the opposite direction of the force, but it is good in certain cases. For an example, if you can take your clutch in an automobile or your brake in an automobile, it is wholly depends on the friction. If there is no friction means clutch won't transmit power, brake won't decelerate your vehicle. Therefore, in certain cases, friction is very good. At the same time, while we are walking in a road, while the vehicle is going in a road, if there is no friction, definitely the accidents may cause. If there is a friction, if there is an allowable amount of a friction, the vehicle will move and vehicle will have certain other parameters, can influence in the other parameters. So this much of importance have to be given on the friction. So with this information background, I'm going to start friction. First of all, friction is a force. Generally, friction is a force. Simply, it is called as a force. It acts opposite to the direction of a body in motion. Whenever, if a body is moving from left to right, the friction force is acting all the way to right to the left. That much simple. We can easily understand the friction or the force of friction. Here, generally, the force of friction can be divided by two types. One is a static friction and another one is a dynamic friction. This dynamic friction is also called as a kinetic friction. In static friction, friction experienced by a body at rest, where in dynamic friction, the friction experienced body in motion. That is the difference. If the friction is experienced by in the body in motion, then it is called as a kinetic or dynamic friction. If the body is stable or a static, it is called as a static friction. And the dynamic friction, it can be also further divided into two types. One is a sliding friction, another one is a rolling friction. In dynamic motion of a body, of any dynamic motion of a body, the body can either roll or slide. Therefore, if the body is in slide, if the body slides over another body, then it is called as a sliding friction. When the body is rolled over the another body, it is called as a rolling friction. When we are walking in a road or when we are walking in a ground, we are experiencing or we are producing sliding friction. If any cycle or a bike or a car is moving in a road, the tires are rolling, therefore it is having rolling friction. So this is the simple example of the sliding and rolling friction. And there is a third type of a friction which is called as a limiting friction, because static is an case and dynamic is an another case. Static is one extreme, like dynamics is an another extreme. Between that, from static to dynamic, there is a friction which is called as a limiting friction. If a body isn't stable, say at the ground, zero acceleration and zero force, if we want to move a body, the initial friction, which is called as a limiting friction, when a body just begins to slide or a roll over the surface of the other body, this is called as a limiting friction. We can say the limiting friction is more than that of static as well as the dynamic friction. Once it get moved, a body is moved from rest, then the dynamic friction is coming to picture. Or when the body is in the rest, the static friction is coming to picture. The between these two, the limiting friction is there, which is very very huge, or which is more than both static as well as dynamic friction. Next, the law of static friction. Now we are interested to discuss law of static as well as the law of kinetic or dynamic friction. First, we are going to discuss about law of static friction. The friction or a force of a friction is always act in the direction opposite to that in which the body tend to move. Therefore, the static friction or a dynamic friction is always act opposite to the body tend to move. Next, the magnitude of force of friction is exactly equal to the force which body tend to move. If I am saying I have a body of 100 kg weight or 100 kg force I am having, then my force of friction is always 100 kg. If I want to move those 100 kg body with the help of 10 kg body, it can't move because the friction force is 100 Newton. Okay, I'm having 1000 Newton of weight, then I am applying 10 Newton of force to move the 1000 Newton of a body. It won't move because the friction force is always 1000. If I want to move such body, I have to apply 1100, then only it can move. So that is the meaning. And the force of friction is independent of area of contact between two surfaces. Yes, exactly. You have to note down this point. It is independent of area of contact, but it depends on roughness of the surface. You can see this. It is independent of area of contact. Either it is a point contact or line contact or a surface contact. It won't taken care of those contacts, but it taken care of the roughness of the surface. Next, the magnitude of limiting friction bears a constant ratio to the normal reaction between two surfaces. So, the magnitude of limiting friction bears a constant ratio, as I said, 100 Newton force cannot be enough to move a 1000 Newton weight. Okay, that is the thing indicated. If you want to move those 1000 Newton weight, you have to give at least 1001, but 1001 won't move the body again. Therefore, you have to give 1100. So that 1 to 100 is the limiting friction. Next, the law of dynamics or kinetic friction. The friction force is always act in the direction opposite to the body tend to move. So that is the common for law of static as well as the dynamic friction. Where the differ point is the magnitude of kinetic friction bears the constant ratio to the normal reaction between the surface. And the moderate speed, the force of friction remains constant but decrease slightly with increase in speed. If we increase the speed of a body, the friction force is slightly reduced. But in the moderate speed or a low speed, it won't change. That is why if a vehicle or a bike is in economy condition, when it is riding at the 40 or 50 kilometer per hour speed, if we brake it, we can easily brake. Or if we are riding a vehicle at 100 or an 80 kilometer per hours, that much huge velocity, we can't easily stop the vehicle. Why? Because at the higher speeds, the dynamic friction loses the value. Therefore, if we increase the speed, the dynamic friction or a kinetic friction will reduce. That is the meaning here. I hope you have understand the law of static as well as the dynamic friction. Next is the coefficient of friction. Coefficient of friction and limiting angle of friction are very important concepts. The coefficient of friction is the ratio of limiting friction to the normal reaction. The limiting friction, that is F divided by normal reaction, is N. The difference between these two forces is called as coefficient of friction. This coefficient of friction, the range is always 0 to 1 in static condition, and moreover the coefficient of friction should not more than 1. That we have to understand. If it is more than 1, what will happen? The body will not move. At any cost the body will not move, and it is not there in all the cases. Okay, when F is the weight of a body, let's say, and Rn is the force I'm going to apply and tend the body to move. If it is more than 1, then Rn is less than F, therefore body won't move. If the Rn is more, normal reaction is more, the body tend to move, and that condition your mu will becomes uh, 0 to 1 value or less than 1. Next, law of limiting angle of friction. Limiting angle of friction. Angle at which the resultant make to the normal reaction, that is called as a limiting angle of friction. Where limiting angle of friction or angle of friction denotes by phi. Tan phi is equal to F by Rn. We already know that F by Rn is equal to mu. Therefore, tan pi is equal to mu. That means the angle of friction is depends on coefficient of friction here. This is our understanding. The angle of friction is depends on the coefficient of friction. Next, angle of repose. Angle of repose is the angle of inclination alpha of the plane to the horizontal at which the body just begin to move down the plane. So here I would like to give an example. We all seen that when a dumper truck dumps any sand or a pebbles or a rock, if just the tipper, just the tipper, if it slides, move and certain angle, so at a plane angle at 180 degree or a 0 degree angle, the pebbles is kept at stable condition. When we incline that tipper, say 0 degree to 1 degree to 5 degree to 10 degree, at certain angle, the body will slide down. So that is when the angle, it tend just a pebble or a sand to slide down to the ground. That angle is called as an angle of repose. Here we know that uh, W sine alpha is equal to F. Therefore, mu F is equal to, we know that mu into Rn, that is equal to mu into W cos alpha. Sine, it will come into cos. And we all know that tan alpha is equal to mu, that is equal to tan pi. Therefore, it becomes alpha is equal to pi. Alpha is the angle of inclination, where pi is the angle of friction. If these two are equal, then your body is in stable condition. So that is the indication here. The minimum force required to slide a body on the rough surface on the plane when pi is equal to theta, we know that P minimum is equal to W sine theta. Next, we are going to see certain conditions. The effort required to move the body up in an inclined plane and the effort required to move the body down in the inclined plane. In an inclined plane, effort required to move and down. So that is the important cases of friction. First, the effort P is equal to W sine alpha plus alpha plus pi divided by sine pi minus alpha plus pi. Sorry, theta minus alpha plus pi. Here, instead of plus sign here, it is plus indicates move up and the minus indicates move down. So that is the simple. If the friction force, if the friction is neglected, then your alpha or pi becomes theta. Alpha is remains same, pi becomes theta. Therefore, this equation instead of pi we put a theta, uh, and the force is neglected. Therefore, W sine alpha divided by sine theta minus alpha. Here, if the friction is neglected, so both up and down motion, the friction effort is same. If a body is slides on the horizontal plane, let's say our theta is equal to 90 degree, what will happen? The effort is bring into W tan alpha plus pi. Here, instead of plus, we put a minus for move down in the horizontal plane. Where next one is the effort on the parallel to the plane. Effort parallel to the plane, that is theta is equal to 90 plus alpha. Therefore, our equation becomes P is equal to W sine alpha plus mu cos alpha, where this is the effort required to up the body, and instead of plus we put a minus, it will give it the effort required to move the body in downward the motion. Next is an important concept, that is efficiency of the inclined plane. Here the efficiency, which is defined as the ratio of any output to the input. Here, the efficiency of an inclined plane is the ratio of effort required to neglect the friction to the effort required to considering the friction. So here the output is effort required to neglect friction and input is effort required to neglecting friction is our output and input is effort required to considering friction. Therefore, neta is equal to P naught by P. And these efficiencies are very much important in while designing a screw jack. In there, work on the inclined plane principle is used. Work on the inclined plane principle is used. So this principle is applicable on the screw jacks. So this is very important one. Therefore, the included angle, which is tan alpha, is equal to P by pi into D, where P is the pitch of the thread, D is the diameter, alpha is the helical angle. Therefore, with the screw jack, what we are doing, we are either raise a load or lower the load. Therefore, the effort required to raise the load, the P is equal to W tan alpha plus pi. If it is for the lowering the load, instead of plus we put a minus, W tan alpha minus pi. And the efficiency of the screw jack neta is equal to tan alpha divided by tan alpha plus pi. And for the maximum efficiency, that is helix angle, is equal to, at the maximum efficiency, the helix angle, which is alpha, is equal to 45 minus pi by 2, that is pi by 4 minus 5 by 2. On that condition, the maximum efficiency of a screw jack will becomes efficiency neta maximum is equal to 1 minus sin pi divided by 1 plus sin pi. Here you can remember this concept, that is the limiting friction is more than that of static friction and more than that of dynamic friction. In the types of friction, the maximum amount of friction goes to the limiting friction and the minimum amount of friction is goes to dynamic friction. The static is in the stable condition. Here we have a certain points to remember, always remember in the friction kind of thing. First concept is the coefficient of friction is depend on nature of surface. It is depends on nature of the surface. It is independent of area of contact, that you have to know. These question in all the interview point of view and all the exam point of view, they have asking, if a ladder is resting on a smooth ground and leaning against a rough wall, the force of friction is always act upward and its upper end. Where the ladder is resting on the rough ground and leaning against the smooth vertical wall, the force of friction is at zero at the upper end. Here we want to understand the Coulomb friction. The Coulomb friction is the friction between dry surfaces. If any friction between two dry surfaces, this friction is called as a Coulomb friction. And next one, the zero angle of friction implies the friction force is zero. If anywhere, if you feel that the friction is zero, there the angle of friction is also zero. The limiting friction of force, the force of friction or friction force acting when a body is just begins to move or just about to move. Next one, the tangent of angle of friction, which is called as coefficient of friction. The coefficient of friction is always tangent to the angle of friction. Here these two concepts is very important in the form of a friction as well as the screw jack, where pi is greater than alpha. When pi is greater than alpha, alpha is the helix angle and pi is the friction angle. If friction is more than helix, then it is said to be self-locking and it is moving upward direction. Where your phi is less than alpha, that is force of friction is less than helix angle, it is called as an overhauling and it is in the downward direction. We can easily remember by means of a story, which is US போனா பை நிறைய காசு வேணும். Like that we can easily understand. This is a mnemonic kind of a code So if we want to go in United States, we need a pocket full of money, and we can earn pocket full of money. So with this U and S, that is self locking self locking upward direction, and pi should be more. Therefore, by this concept we can easily understand US போனா பை நிறைய காசு கிடைக்கும் or பை நிறைய காசு வேணும், like that. I hope that you have enjoyed the session. So I hope I have given an enough details about the friction. If you have any doubts, please let me know in the comment section. I will put another video for your doubts. Thank you all. Thank you for your support.